thinking.
Live.
There we go. It's live.
There we go.
Okay.
Let's try it again.
Okay. So we did number 1. Mark said it was null hypothesis.
Mm-hmm.
Number 2, does the alternative hypothesis below represent a one-sided or two-sided alternative hypothesis? And because it says the null hypothesis is equal to 0 and then the alternative is greater than 0, it's one-sided. Because if it was two-sided, that alternative hypothesis would have had the not equal to sign, right, Mark?
Right. Yeah, so whatever side the little point is pointing to is what side the test is. So the arrow's pointing to the left, so it's a left-sided, one-sided up to the left.
Okay. That's a good way to remember it. Okay, so fill in the matrix below with the correct responses, and so in the first box, I put that fail to reject the null hypothesis, and then hypothesis 3, I put correct decision.
Mm-hmm.
And then you could do it if you could do the other 3 boxes. Like.
Okay, you went
Well,
through the... Oh, go ahead, Jeanette.
It's I have a correct, or it's the first box on the left. The bottom box is I got trial 1 or type 1, and then the top right box is type 2, and then correct. Correct?
Yeah,
Right.
correct.
Correct.
Okay.
Correct.
Okay,
Okay.
number 4, the final level of significance in a hypothesis test. With which Greek letter is it denoted? And it's the alpha funky looking A.
Mm-hmm.
And I put helps us determine when we should accept or reject the null hypothesis, or that it's the number used to determine if the p-value is small enough to reject the null.
Yeah, but it's also the probability of making a type 1 error. So, I mean, that comes in handy a little bit later, but if you've got like A equals 0.05, then you've got a 5% chance of a type 1 error. Does that make sense?
Yeah.
Yeah.
Okay.
I'm working on that one. Okay, it'll click soon. Number 5, write down the formula for computing the test statistics for the hypothesis test for a single mean when sigma is known, and that's the one we've been using.
Mm-hmm.
The x bar minus the mu divided by the
Standard deviation.
and over the square root of n.
Is it Christmas somewhere?
I keep hearing.
It's ice cream.
I am down at my mom's house, and I'm hiding in her happy house in her RV, and that is a clock that does that every hour. So there's too many grandkids running and screaming in the house and having fun.
At first, I was like, kind of my head. I was like, kind of sing along. And I'm like, wait, where is that coming from?
Yeah, it was a gift, and she's left it up, so because she's that way. Where were we? Number 6. Define the p-value. How is it in a hypothesis test? So it's the probability of obtaining a test statistic at least as extreme as the one you calculated.
Yeah, am I the only one? The wording on all of these definitions are so confusing.
No,
Yes.
I had to go over things several times.
I still don't understand the definitions. Like, I learned what the math is, but as far as like, yeah, so it's whenever this is not this, or is at least as extreme as the outcome of this potentially. And I'm like,
Yeah, it's too. It's like it sounds like it's a broad statement. Like, what? Okay, well, what is more extreme? Like, how? What is your definition of extreme?
yeah.
You
I
know,
don't
it's just like,
get the definition.
okay.
I'm glad that y'all don't either. That makes me feel better.
Yeah. Get on the boat, Mark.
No, don't get on the boat. We need him to be off the
Because
boat.
I'm like, I read that and I'm like, wait a minute, what did that just say to me? Like, I would like, some numbers or some kind of qualifications or something in there so I can understand what that's actually telling me.
We're so glad you're here, Mark, and we're so glad you get so many things.
Well, that you're so nice to us.
Yes.
Okay, number 7. If the null hypothesis is rejected in a hypothesis test, what is concluded about the alternative hypothesis? And so if you reject the null hypothesis, it means that you had enough evidence to conclude that it was true.
Yeah.
Okay?
Yes.
I say yay because I'm so happy when I get them right.
I know, it's like, it feels like you break down the mental block. That I have a huge mental block with math. It's partly because I hate it, and then partly because my brain doesn't quite think that way, so it's like I have to pound against this wall. So when I get things right, I'm like, yes.
So what did you guys have for number 7 then? What did you guys write down?
When you reject the null hypothesis, it means that you've got enough evidence to support
the alternative,
or enough evidence against it, or no.
You have evidence
against
the null hypothesis, or to show that the alternative hypothesis is true.
Yeah.
Okay.
That makes sense.
No, but let's go on.
Well, no, let's.
This one's pretty easy though. We can.
For like an example of rejecting a null, like let's say the null hypothesis is, what's like an example? Like.
So like the judge, if you're guilty or not guilty, it's never they say that you're innocent.
Right. So the null hypothesis is that you're innocent because you're innocent until proven guilty. Right.
Mm-hmm.
So the null hypothesis, you are innocent. And so in order to reject the null, there needs to be sufficient evidence to support the alternative. And the alternative would be that you're guilty. So if you reject the null, that means there was sufficient evidence.
Saying that they were guilty.
Does that make a little bit more sense?
Yeah, that does. Thanks.
If it doesn't, we can talk about it, because there's no point in going on if y'all don't, you know.
It's just... It's
the wording.
Like,
It's the
wording. It's the wording. It really is. Like, I read the chapter, and I'm thinking, going, why am I bother even reading this? Because this is just like Greek to me, basically.
Yeah.
Even using Greek letters. And so it doesn't make sense until I watch those videos. And like, okay, that's what they're saying. Like, if I read it, I can get the examples and understand, but applying it when they ask me these wordy questions, I'm like, what are they even asking me?
Just like a good general rule is if there's enough evidence, then you reject the null. If there's not enough evidence, then you fail to reject it.
So basically,
so like the null is always... What?
Go ahead, Mark.
The null is always going to stand. Like, you can never, like, reject the null. Does that make sense? Like, you can't reject a null because the null is what it is. The null is equal to whatever. So if there's evidence, then you accept the alternative. But if there's not enough evidence, then you fail to reject the null.
So then the null would still stand.
Right.
Okay.
So if you have enough evidence, or sufficient evidence, it's whatever you want to put that.
Yeah.
You have enough evidence to support the null, then you...
If there's enough evidence to support the alternative, then you accept the alternative.
So,
but
for example...
If there's insufficient evidence to support the alternative, then you fail to reject the null.
So, like, the world, everyone used to think the world was flat, and so that was the null hypothesis. Then when Columbus discovered it was round, he didn't fall off the end of the earth. There was enough evidence to reject that null hypothesis because they knew that the world was not flat because they had enough evidence to support it. So for the last 600 years, almost 500-600 years, we believed the null hypothesis has now been that the world is round, and tomorrow someone could figure out that it's triangle, and then that we would reject that the world is round, and it would now be triangle. So,
and then you would accept the alternative, which is the Earth is a triangle, and that becomes the new null.
And the null is only truth as we understand it or as we know, for whatever evidence we have for it.
So if we have sufficient evidence to believe the null, that everybody believes it, then if there's another hypothesis that comes in, we need to have sufficient evidence to believe and accept the alternative hypothesis.
Yes.
Okay. That just sounds like a bunch of jargon coming out of my...
I feel like we're in law school. This is crazy.
I know.
We're like,
I just want to say I object.
I feel like a tax writer.
Well, my problem is too. Okay, like, how am I supposed to apply this to my life? That's what I want to know.
I don't know. I didn't even do number 8 when it's just like, think of a real life situation. I was like, no thanks. I'm okay.
There isn't any. Keep going.
I tried to think of some, but I
What'd you
couldn't.
say?
Oh, I thought of like, what about athletes breaking records? I'm like, no, that wouldn't be. And then I thought, well, what about if your null hypothesis was that this new recipe was going to be really popular in a restaurant? And I thought, well, maybe that's not it. Or what about if your null hypothesis is that this car will get 40 miles a gallon? And then, like with my Hyundai car, that's what they said. And then they found evidence to reject that hypothesis. And now they give me a credit card with money on it every once in a while because it doesn't get quite as much as what they said. So
See, I thought about cars right away too, because that's the gas mileage. That was an example in one of the chapters last, couple lessons ago. I'm like, gas mileage. That sounds good to me.
maybe
And
that's why.
we do keep track of our gas mileage and stuff. So
Okay. All right, so part 2, number 1. The Graduate Management Admission Test, the GMAT, is... Oh, they used that acronym on our last
They use
Yes.
it all the time. That and the
What the
milk
heck
jug
is
one.
GMAT?
we
Okay.
talked about the GMAT.
Okay, the GMAT is used as an admission criterion in many Masters of Business Administration programs. The scores on the GMAT in the past have a mean score of 529, and the BYU professor feels now that the scores improved within the last couple of years. So the null and alternative hypotheses would be the mean is the null is mean is 529, and the alternative is greater.
Yeah.
Mm-hmm.
Okay. B, suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. Was a type 1 or type 2 error committed? And I had to go back and look at my box to figure it out. What did you guys put?
It's a type 1.
Type 1, right?
That's what I put,
Mhm.
was type 1.
I'm going to have to go over those again. I know those aren't super hard, but it's just getting the wording to match each. Type 1 or type 2.
Yeah, me too.
That one's not that hard. You just got to memorize which is
I
which.
just have to I have to remember, like memorize it. You have to remember which one is which. Yeah.
It's brand new. So, and then on C, if the analysis was done at alpha equals 0.01 level, what is the probability of coming to a type 1 error? So if it's 0.01, it's a 1% chance, or 1 in 100.
Yeah.
Like,
Now, will it always be, what am I trying to say?
Will always be
To
0.01?
100? Obviously, yeah. So then because we're trying to find a percentage, right?
right.
Probably
It could be
always
0 to 100%.
Got it.
And whatever that is, that's the chance of that, is that probability of that specific thing happening.
Yeah. Okay.
Okay, if we wanted to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance?
You need to increase it.
That's what I put too.
Yeah, because it's, what did it say in the notes? It said, when one goes up, the other goes down.
Mm-hmm. Oh. And I understood it when I got the answer, but now I can't remember what I read and why I got increased, but I did, and I'll go back and I'll read it again.
Well, if you remember that the level of significance equals A, like A is the level of significance, and that's also the likelihood of committing a type 1. So if you increase the level of significance, then you're increasing the chance of getting a type 1 error.
Okay.
So if you increase the type 1 error, you're decreasing the type 2 error.
Mm-hmm.
Does that make a little bit more sense?
A little, yeah. Yeah. I'll practice more. It will come. Okay, number 2, a study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation was 5, a real estate agent wants to determine if the average age of those buying investment property in his area is different than the national average. He randomly selects 15 of his clients who purchased an investment property and obtains the data shown. So I figured out SPSS.
Oh, I don't even want to talk about that program.
Chelsea, did you get it to work for the test or not? No?
No, I told you to call me and I would put it on.
I know, but it's so late your time. I mean, I got I finally got the thing to pull up that had the list of the 143 numbers. That came up, but I can't open up anything else. So it's like, it's just the numbers, and I can't plug in anything to the to the SPSS or whatever. So I did everything else on the test, and then I wrote down every freaking number, 143 of them, and had to do it that way. And yeah, so and it was like the last ones that I was doing. So I mean, I think I did the mean and the median.
Did you tell him that?
I haven't. I need to email him because I literally finished like right before it was due. It was really fun. So I mean, he emailed me this morning. Like when I got up this morning, he'd already gone through my test or whatever, and like told me the answers or some of the answers. But I'm gonna email him back and just say, hey, just so you know that it wouldn't work for me. So I don't know if he'll do anything about it or not. So I may just even have him or somebody work with me on the SPSS, because I mean, if we're going to be using it the rest of the semester, and it does not work at all for me, like at all.
Well, mine. Remember, we were having a meeting the other night, and mine was sporadically downloaded again. Mm-hmm. It has downloaded 3 more times after that.
Oh my word!
So I don't know what is going on, but it worked for my test. Yeah.
See, and I have never once gotten the SPSS whatever it is to work. Like I can never plug anything in. I can't use, how sometimes you guys will explain, well, okay, go to the top and click graph, and then you click this. I've never once been able to do that.
Because you've never seen it. It's never opened up at all.
Mm-mm. I won't. And I bought the dang program, and I've downloaded the other one. Yeah. Or if I can get one to pop up, then the download stuff won't come up, or it's a hot mess. That's what it is. It's math saying I hate you, Chelsea, is what it is. You know what? It's okay because I hate you too. Anyway, so I'm going to have to email him and just see if he can meet with me and just kind of try to walk me through things or something. But anywho, proceed.
Okay, so do you want to see?
Yeah, if you will show me. I mean, I'm totally down for learning. It will not even open up on my computer. So if you want to show me, I would like to see.
Okay. So I put the numbers in. I copied that box and I put it into Excel. And then I put it into Excel, and I found out I couldn't get it to work at first, and so I realized I had to make another column, and I just labeled it like client number. I gave each client a number, and then I plugged it in over in here. Can you see that?
Yeah.
Okay, so client number and client age, and I was able to change the variance by going over here to variable view, and I did 0 decimals, and anyway, so I got it plugged in there, and then I can go to analyze, statistics. What the heck?
Do you have headphones you could put on? That might help.
Maybe. I'll just hurry through this part. So I put the client here. I go into plot. And I always click these. And options. Statistics. I don't need those. Okay.
It's not showing anything.
it still echoing?
Yeah.
Yeah.
After this,
Here,
I'm going to be...
everyone mute their microphones and let's see. Except for Shansi, you keep.
Okay, so this is what it brought up. And so on A, it says, design the study. What is the population from which the realtor obtains his data? How did he obtain this population? And what is the research question? And I put that the null is equal to 47 and that the alternative is not equal to 47. And then the researcher wants to know if the average age of people buying investment properties in his area is different from the national average. He collects info from the population of second home buyers and randomly selects a sample from his own clients. Does that sound like what you guys have?
Yeah, I didn't get anything for that one because I couldn't pull up anything. So.
Oh. Okay.
Yeah, can you go over your the case processing stuff again that you put in there? Sorry, you kind of cut out on part of it.
Right here?
Yeah.
I didn't go over any of it because we don't need it just yet.
So where did you find like your answers for the problem?
Okay, so on A, the answer is in the question itself because the average age of a second home buyer is 47. And so his alternative, now it wants you to go through all the steps to design the study. And so the null that you would create is, the null is 47. And he wants to know if the people in his area, if the average age is 47. So his alternative is that they're not 47. Does that make sense? And then on B, if you collect the data, name at least one way the realtor could have randomly selected a sample. So I thought maybe he could make a list of all the second home buyers. This is really weird with you guys on mute. Made a list of all the second home buyers, picked a random starting point, and then sampled every, like a stratified. But I don't know if that's what they were looking for. What did you guys put?
Oh, wait, where are you?
On B.
B. Oh, it's getting weird.
Yeah, it has been like I just put that he made a list and then he started at one, like start at 5 and then do every 3 people. Like
okay.
what? That's
like stratified.
Yeah.
Okay.
I get it now.
Okay. Moving on to. You want to move on to C? Okay.
Yeah.
Okay. Describe the data. Graph the data on a histogram. So back over to here, I just went down because I made sure I clicked on the thing when I created that we could draw the histogram, and so that's what it looks like. So they want you to sketch it or cut and paste it on your electronic copy, and then in a short paragraph describe the data by using at least 5 descriptive statistics, and I didn't get 5, but I said it looks approximately normal. And the approximate age. Go ahead.
I wouldn't call that a normal distribution. That looks to be more left skewed.
Okay. I kind of wondered about that, but
because normal would be an arch, like in the middle. The highest would be in the middle, and then they would go down from there. Would be normal.
Well, the normal was 47. 20. Yeah, it went. Yeah, it's left skewed.
Yeah, because it looks like there's more older people investing than younger people investing, so it's, I would say, right skewed as well.
Okay.
Or left skewed, I mean, meaning all the data is on the right.
Okay. So what are some of the things that you guys put on in a short paragraph, describe the data by using at least 5 descriptive statistics. So it's left skewed. The approximate age is 46.733, which is right there next to our histogram. It gives us that. What else?
And then the mean, you can put the mean in there too, since we know that.
Oh yeah, mean is
47.
well yeah.
Yeah, rounded.
And then the standard deviation was 8.827. Mark, you're quiet.
And that's 4 right there. How many did it say? 5?
Yeah.
It said 5.
Do like the range or something. Just do 56 minus 27. Is that 29?
Yeah, looks like it. We can come up here.
Yeah, it's 29.
We could use some of the stuff from the descriptives box. The median is 49.
There we go.
What did you say the mean was? 49? I missed it.
The
47.
mean is 47. The median is 49.
Median.
Mm-hmm.
That's
The standard, and then the standard deviation is the 8.827. The minimum, yeah, it's 27, and the max is 58.
Well, that's 2, 4, 6, 7.
Perfect. Okay, so moving on to D then.
Yeah.
Check the requirements. Since there are only 15 pieces of data, what will you need to check? And I put, we'll need to check and see if it's a normal sample. And I got, honestly, I got stuck after that, so I looked over at the answer key and it mentioned the QQ plot. So.
Yeah, so what that's saying is you need to make sure that since there's not a large sample, because you remember that if it's a large enough sample, then it's automatically going to be normally distributed.
Because of love.
Right.
Right, the central limit theorem. It's saying that since there's not a large group, how can you make sure? And so it's just saying graph it just to make sure. That's all that it's saying.
Okay, that's good
So
to
there's
know.
our QQ plot right there. Can you see it?
Yeah.
Oh, yeah.
So, what would you guys say? Is that fairly close to normal, or we've got?
That's fairly close to normal.
I would say so.
It almost looks like that snake one they talked about in the.
Oh,
Yeah,
yeah.
This one's
normal.
that one's kind of
normal would be everything would be on that. It would be like a complete ... all the way on the line, right? So that would be not normal because it snakes up and down, right?
Yeah, think about it this way. If that graph is not a normal distribution, then the QQ plot is not going to be normal either.
Yeah, 'cause that would make sense if histogram is less
Yeah.
right skewed.
Oh, that's good. Thanks, Mark. Okay, so part 2, state the null and alternative hypotheses, and if this is a one or two-tailed test. So
we know that it's 47, the null.
So the null equals 47. Okay.
Yeah.
And then the alternative, remember,
does not equal 47.
right? And because it says do not equal 47,
So
then
it's two-sided
Mm-hmm.
or two-tailed,
Yeah.
whatever you want to call it.
Yep.
Okay. Yay.
And then let alpha equal 0.05. So on part 4, compute the test statistics. What is the formula to be used? And it wants us to remember the statistic will be a z-score. And after writing down the general formula, input the numbers you will use, show the work. Finally, use something to compute your statistics.
Okay, quick question.
Okay.
So the what is the formula that we were given? So the new one is the z equals the x bar minus the null hypothesis divided by standard deviation to square root n, right?
Mm-hmm. Yeah.
So is that what this one is talking about? Is that one?
Yeah. I remind myself. Yeah, because we have the standard deviation, we can use that one.
Okay.
Right?
Yeah, that's like the entire theme of this lesson, because the standard deviation is sigma, and this is finding it when the sigma is known. So we're always going to use that formula.
Okay. And when I looked on the answer key, let me hold on, zoom in on it. Okay, so when theirs, they have like the Z and the little, zero sign. What would you call that?
The null.
Okay, so that's exactly what that means. So this one, because in the what is it? In the recording that I watched or whatever, it has that. That's not this. It doesn't look the same as the one that was in the.
Right. Yeah.
You know what I'm saying? So that's why sometimes I start to get confused. I'm like, okay, so is this one? I don't understand that. What is that formula if that one's different than the one that was in the readings?
It's the same formula, but all it's saying is that's the z-score for the null hypothesis.
Because we could also, yeah.
Yeah, because right now we're testing to see what the null hypothesis, like we're seeing if the null hypothesis is true or not. So this is just finding the z-score of the null. That's all that it is.
So it's basically labeling it. Is all.
Okay, so we would use 0.5
as the standard deviation.
As the standard deviation. No, because it's the A. So I'm confused as to where we'd use the 0.05.
Okay, no.
No, we're not going to use 0.05 yet. That's going to be later. What we're going to do is we're going to solve for this equation, and then once we get our answer, we're going to then compare that to 0.05. But 0.05 isn't in these calculations.
Okay, but
so
5
go ahead.
5 in the problem is the deviation that it said back on at the top of the other page. Standard deviation.
Right. I thought that you said 0.05.
I did. I said 0.05.
Okay. I missed that. Sorry.
So when do we use that 0.05? Just later on?
Yeah, that's just going to be a comparison.
Okay. Oh, okay.
We're going to accept a
so that's our null.
Yeah, that's kind of like our measuring stick. Like if it's greater than that, then we have evidence. If it's less than that, there's no evidence.
Got it.
Okay. All right. So up here, I've gone back, and our mu is 47. That was in the story problem, and then x is, where did it go? 40 is the mean right here that we figured out. It's 46.733. So, and then the standard deviation is 5, and the number is 15. So you plug that into the equation, 46.733 minus 47 divided by 5 over the square root of 15. You guys have that, or do you need a minute?
Yeah, will you say that again? So it's this
46.733 minus 47.
And then it's divided by the standard deviation, which in this one it was
5.
5.
Over the square root of 15.
What did you guys get?
Negative 0.207.
Yeah, I got it right.
Okay, say it again. Let me see if I got the same one.
Negative 0.207.
Yes.
Do you know what I got? An awesome new calculator. I'm like, I'm screwing up, and when I do it longhand, there's too many steps. I'm like, $15.
There you go.
And my cell phone that's just too small. I'm apparently it just makes me upset. So I just want to throw my phone, which is never a good idea. So, and by this point it's almost dead. Yeah, I have 28% battery left on it today, so it's almost dead every day. So.
Okay, so now that we've got that, are you able to pull up your normal probability applet and plug it in? And you're going to color in both sides of the tail, or both tails.
Okay, why do you need to put in both?
Do you remember?
How do you know when to shade? I guess.
If you look back on point 2, on Roman numeral 2, it says that this is a two-tailed test because it's not asking if we only shade one side. If it said he has his alternative hypothesis is that the average age of people is younger than 47, then we would just shade to the left. Or if he said he thought that the average age was older than 47, then it would be to the right. Yeah. But he said that it's just anything other than 47. So we're going to shade both sides. We just figured that out from looking at the alternative hypothesis. If the alternative hypothesis is the equal sign with a bar through it, then it's always going to be two-tailed. If it's pointing to the left, then we're going to shade on our probability applet. We're going to shade to the left. If it points to the right, we're going to shade to the right.
Okay.
Okay, and then
well, that makes sense. Okay, so it's two-tailed, then it's does not equal the equal sign with a line through it. So when it's less than, we're shading to the left, right, greater than, shade to the right. And then you said it's two-tailed, then we shade both the ends.
Both ends, yeah. Mm-hmm. And when do we shade the middle? Then just the middle. You ever do that?
Well, it depends on the z-score that you get. Like this one, our z-score is negative 0.206. Right? If our z-score had been any kind of positive number and we were looking for anything less than that, then we would shade everything to the left of a positive z-score, and then you would shade the middle.
Okay.
Does that make sense or not really?
When it's a positive z-score, you shade everything? Like, the middle and to the left? Is that
It really depends on what the alternative hypothesis says. So, like, if the alternative hypothesis was that the national age was less than 47, and we had done our calculations and got a positive z-score, then it would be asking us to find everything to the left of that z-score. Okay. So, because you know how in the probability applet there's two z-scores, one's negative and one's positive?
Yeah.
Mm-hmm.
So if we ended up having a positive z-score and it was asking for everything less than that, then the middle would also be shaded.
Shaded, okay. That makes sense. Okay. And then if it was asking for the opposite of what you just said, then you would do the other side, right? The middle and the other side.
Mm-hmm. Right.
Okay.
Yeah, it really just depends on what the alternative hypothesis is. But this one's just saying anything but 47. So we're going to look on either side.
Okay.
Perfect.
Alrighty. And not to rush you guys, but I do have half an hour for my next class. Joy.
Right. So
I'm sorry, I always have other classes.
We're almost done anyway.
I'm going to step in.
Okay. So on section 5. Oh, I thought you were talking about
what we got. So if you plug it in the applet, I got 0.836.
Yep, me too. Okay, so that's our p-value. Okay, so in section 6, compare the p-value to the level of significance, which is the alpha level. And so do we reject the null hypothesis or fail to reject the null? So I wrote down the p-value is 0.8360. The alpha was 0.05, if you remember.
Yeah.
And so
what are you on?
6. The Roman numeral 6.
Compare the p-value. It's right under the graph. Under the p-value dome, whatever. In the applet.
Okay. Compare the p-value to the level of significance, level A, level do we reject or the null hypothesis? Okay.
I had to write it out to help myself. So the p-value was greater than the alpha, and so we failed to reject the null hypothesis.
Okay, so the p-value is 0.836.
Yeah.
And then the formula was x equals x bar subtract. This is the formula that we've been using forever. Okay, so the p-value is 0.836, and the other one is so with A alpha is 0.05 is what we're comparing those two now, right?
Right.
Mm-hmm.
Okay, so do we reject or
We
fail
failed.
to reject?
We failed to reject.
Why?
Is it because the 0.836 is greater than? So that's, wait, no, because if we're failing...
Hang on. What does the answer key say?
It said fail to reject, but I don't know why.
It says we failed to reject?
Mm-hmm.
Yeah.
So,
What does it say under the next question? What does it say there? I don't remember.
Conclusions.
Yeah.
There was not enough evidence to conclude the mean age of people buying a second home in his area is statistically different from the national average. And I'm a little hung up on this one because I wasn't quite sure, because to me the numbers look pretty different from the p-value and the alpha. So maybe we can ask him in the meeting next week or something. But
Well, that's what kills me is it's next week. Like
Hang
I
on,
think
let
we
me
need it
think.
now.
What does it
Let me think
say
real
in the
quick.
end? Okay.
Okay, so the p-value has to be smaller than the alternative, or smaller than the a value to reject it.
And it's not.
It's not, so we fail to reject it.
Okay, so it must be smaller. Oh.
What was it? What must be smaller?
The p-value.
The p-value has to be smaller to reject it.
Has to be smaller to reject the null.
Okay, it's probably a silly question mark, but why does it have to be smaller if we're looking for anything?
Because the a value represents the probability of committing the error or to reject it. Because the type 1 error is rejecting it when it's true. And so that's what A represents. So A means there's a 5% chance. So we had a greater than 5% chance, which means that there probably wasn't
enough data.
False.
Okay.
Right. So if the number is less than that, then it means that it's kind of like saying there's a 5% chance of winning the lottery or whatever, and I don't even know how to, that's a terrible example. Just forget that I said that. Basically, if the number is smaller than the A value, then there was enough evidence to reject it. If the number is bigger, if the p-value is bigger, then we keep it. It's almost like a barrier. Like, if the number is less than that, then you reject it. But if you met it, like if you've hit that limit and you're past it, then you're safe.
Okay.
Okay. Reject. So less than the A, keep it. If it's greater, reject it. Okay. All right, moving on to E, take action.
One more quick question. Okay, so the null is it the same as the A, the alpha, or is it something completely different? Because we're kind of using it as both the null and the A, and I'm getting a little bit confused.
What do you mean?
Because it talks about we're using A, but we're also using it as what we're comparing it to, which is we usually compare it to the null, right?
Well, the A is...
Yeah, well, the A value represents the possibility of rejecting the null when it's true. And so that's why we're still using...
Okay. Got it.
Okay, so E, take action. What would you suggest the realtor do with his statistical conclusions? And I just wrote that he continued to target the older age range, the 47-ish, to invest in a second property.
Yeah. That would make sense.
Okay.
I thought about it as it doesn't matter how old people are buying or how old they are, their age, as long as he's continuing to sell property, so continue doing what he's doing, because selling property is selling property.
Yeah.
And if you're targeting people who want to buy houses, so that's everybody, isn't it?
Well, it's everybody, but based on the data that was collected, it showed that he's more likely to get someone as a buyer for a second home buyer in that age group, because there's more of them that are doing it.
Right, in the like in the older spectrum, I guess.
Yeah. As compared to someone who's in the early 20s.
Right. Well, then you also have those outliners too. That's like 27 and 30. What were they? They were like super young. Yeah, 27, 35, 38, 38.
I think I saw Mark's name on one of those ages, so he'd be one of those.
Yeah, right. I'm only a few years off. I don't even have a first home purchased.
Well, that can change really fast, Mark. If you win the lottery, share.
You know what? I wouldn't be pissed if I won the lottery. Just being honest, that'd be okay with me.
Me too. I promise I'll do some good with it. It won't be just for myself.
Right?
Right, exactly.
Okay, so going over to the group meeting, and I'm almost out of battery and I don't have a plug. So.
Let's blast this group meeting.
What did you say, Mark?
I said let's blast through it then, because you've got a meeting and Chancey's battery's running out, and I got stuff to do.
Okay, ready? Mark, set, go. Oh, that's kind of funny. Mark. Mark, set, go.
I know. I kind of thought you were talking to me for a second, then I realized that you were.
Me too. Okay, number 3. A hypothesis test consists of 2 hypotheses, the null and the alternative. Which one represents the status quo, which is the null?
Yeah.
Correct.
And then 4, what hypotheses involves equality equals the null, right?
Mm-hmm.
P-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information. Mark, that definition you just gave us a minute ago, that helped right there with what that said. Thanks. So use this information to answer question 5. When computing this probability, which hypotheses do you assume to be true?
You guys, mine's not even open yet. Hold on, please.
Well, we're sorry, Jeanette. We're done.
Okay, so then it's number 3 is null, right? Number 4 is null.
And 5 is null, right?
And 5 is null? Yeah. Okay.
That's what I put.
Okay. We always wait. I wait for you to make sure that mine's right. I'm like, okay, this is what I'm saying, but make sure Mark's saying the same thing. If Mark says it, then we know we're good.
Right.
Sorry, Mark. We're putting a lot of pressure on you.
We appreciate you, Mark. We'll send you cookies.
I will take
cookies.
Don't worry.
Well,
I wish, we were talking about, Chelsea and I were talking, we wish you lived closer. We'd bake him cookies and cakes and whatever,
Thanks for putting up with us, Mark.
On the road.
Yeah, we appreciate it. We really do.
No problem.
Okay, so suppose the null hypothesis is the null is the mu of the null is 10. So use this information to answer 6 through 8. Which of the following represents the alternative hypotheses for a two-tailed test? Which is the third one.
Third one down.
Yeah.
Because which of the following represents the alternative for a left-tailed? So it's going to be
The less
first
than.
thing,
The first one?
right?
Yeah.
And then 8, which of the following represents for a right-tailed, which is going to be
The
Second one?
greater. Yeah.
It's the second
and
one.
then
Yeah.
the outcome of a hypothesis test is determined by comparing the p-value to this level of significance, or alpha, which relationship would result in failing to reject the null hypotheses. So the p-value is greater than alpha, right? Because that's what we just did on the other problem.
Right.
Yeah.
For the first one.
Does anyone get why that is?
Why the p-value is greater than the alpha?
Mm-hmm.
Or why that's why we reject it? Yeah, we just wrote that down, didn't we?
Or in
Yeah,
failing.
I just want to make sure.
Yeah, because if the p-value, if it is smaller, then we have to reject the alpha.
Right.
Right.
I hope I remember that later. Okay.
Write it down. That's what I
I'm
did.
going to write it down on an index card and take it with me so I can memorize it while I'm doing dishes and stuff.
Oh,
Put it
good.
in my head.
Okay.
Okay, so number 9 is the first one, right?
Yeah.
And number 10 is
number
the second one,
the
Number 10,
right?
which
Yeah.
relationship resulted in for number 10
Less
too?
than-
Yeah.
Yeah.
Okay, an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was about $1,500. They're concerned that the treatment is actually higher. Use this information. Okay, so which of the following would be appropriate alternative hypotheses so it would be greater?
Greater than the third one.
Mm-hmm.
And then 12, which of the following would be appropriate null hypotheses? It's the first one.
Equal to.
Uh-huh. Okay, so they randomly select 40 claims, calculate the sample of the X bar 1650. So where's my pen?
Okay, so the first one, our null is 1,500, right?
Yeah.
So we got to use. Okay, so it's.
Wait, what are you?
Wait, what did you just say?
So X bar is going to be the 1650 minus 15 when we put it in our calculation. 1650 minus
We're not-
1500
We're not
divided
doing
by.
that yet. We don't need to do that
No?
right now.
No.
Oh,
Yeah. We
okay.
don't need to do that.
We're
The
jumping.
insurance companies
ahead
the distribution of the sample mean is normal. Is that a good assumption?
Mm,
No, because it's
Yeah.
a small sample value. Well, it's over 30 though.
Yeah.
Right. Yeah. That's a
would
larger
say yes.
sample.
Yeah, because
yes.
it says it several times in our notes that anything over 30 is considered a larger.
A large.
Yeah.
So it's yes.
Okay, so yes. And then what theorem or law justifies your answer? Because the theorem. Did I hear you guys just say that?
Yeah, central limit.
Yeah, the central limit.
Which of the
which was
following? It was the X bar.
No.
Yep. No, it's not. That's in the equation.
Yeah, it says if you look on question, where is it? That group one that we did under D, where it says make an inference, and then there's like Roman numeral 4. It says compute the test statistic. What is formally used? Recall that our statistic will be a z-score. Our test statistic is the z-score.
Oh, you're so right.
Now, is that always going to be the case, or does it change?
Yeah. Because without the z-score, you can't find the probability, and so you can't compare it to the alpha. So the z-score is the test statistic, always.
Okay, I'm writing that down
Oh,
too.
jeez.
Okay, so
It's Z.
z-score. Can the historical
15 is
mean? Yeah. Sales receipts at a grocery store is 150 with standard deviation of 40. Store manager suspects average is decreased. Set for the test. So her hypothesis, the null is equal to 150. Oh shoot, I'm going to lose this. I'm going to save my thing real quick.
We can just save it and then write down the answers that we get and then put it in later.
Do that.
Okay. I've got 7% battery and it will go quick if I don't
Do you want to go grab your plug-in real quick?
I'm in the trailer. Oh.
You want to go run?
Go run in the house?
Yeah, I'm gonna run in the house.
Okay.
Yeah, because I mean, I still have 15 minutes before my next class, and we'll finish before then. So, do what you got to do, girl.
Woohoo! Love you, Mom.
Mark, where are you from again? I forgot.
I'm from Houston.
Okay.
Oh,
So you're a proud
Houston.
Texan then, huh?
I am Texan.
Right in Houston?
Yeah, I'm from one of the suburbs of Houston,
Right.
from Southeast.
Chauncey, you gonna show us around a little bit?
From, let's see, Beaumont is outside of Houston, away from Houston, right?
What's that?
Beaumont. Is that outside of Houston? A couple hours or
Yeah,
so?
Beaumont is like 45 minutes away. Beaumont is to the east, like a little bit. But it's super close.
Uh-oh.
Did we lose her?
Possibly. Well, if not, she'll be back on in a second. My brother-in-law's from Austin, and he is very proud in Texas.
Yeah.
So we always have to tease him. I found out there was a car driving in front of me yesterday, and it was going so slow, and the license plate said Texas, so I had to take a picture and send it to him, and he's like, "Oh, great," you know, we just always tease him. So funny, like, "Wow, okay, great. Oh, that's why he's from Texas."
This guy, speaking of Texas plates, this guy was driving in front of me. He had a brand new Dodge Charger. I know that car can go, okay?
Yeah.
And he was driving.
And they always go so slow.
And he goes so slow. And I followed him into the Walmart parking lot, and I literally sat there and waited to see, because his windows were all tinted. It was really, really dark tinted, so I couldn't even see in, and I was behind him anyways. So I waited until he got out. It was like this 55-year-old businessman in a suit and tie. I really wanted to go over there and say, I will show you how to drive your car if you would like me to.
I know. I'm like, okay, like, don't buy that kind of car unless you're going to use it. Like,
I know, right?
I think that all the time.
We had a bright yellow GTO stick. It was awesome. That car could fly. And that was so fun. And number 3, we got rid of it, but after the third key, we got rid of it. But because we didn't need 4 vehicles. But it's just like, that car is so fun. And there's this guy driving this Camaro, like, a Charger. It was like bright red with black racing stripes, you know, and he's driving like he's like, you know, it was horrible. I couldn't take it.
I'm glad somebody else thinks like that, because I'm always like, why did you buy a fast car if you're not going to drive fast?
because he can now afford it, because his kids are all gone, and he's like, I'm going to go get the car that I wanted when I was 18 and didn't get it. Anyways, okay. I'll get off my soapbox now.
It's okay. Welcome back.
Thank you.
All right, there you go. There she is.
Okay, so we're on
number 16. Yes.
So she's going to use the level of significance of alpha equals 0.05, random sample of 36, and computes X bar of 144. So what is the Z score? So this is where we plug in.
Deviation.
Jonas, where's my computer bag? Computer bag? Did I put it down here?
So the mean's 150.
The mean is 144.
So X bar, so it's 144 minus 150 over 40 divided by the square root of 36.
Correct.
Okay.
Over 40 divided by square root of 36. Is that what you said?
Yeah.
Right.
Say that one more time. Let's see.
The formula is 144 minus 150 over 40 by the square root of 36.
Wait, over what?
Over 40 divided by the square root of 36.
Okay, so that's minus 6 over 6, which is minus 1, right? If I did that in my head.
The square root of 36 is 6, so it'll be negative 6
Minus
divided
one.
by 40 divided by 6, which is
Oh, I forgot the 40 part.
6.667.
I forgot the 40.
Yeah, let me know when you guys have it.
I got it.
I'm almost there.
Okay, so when I do 40 divided by the square root of 36, it comes out to be 6, and there's a tons of 6s and then a 7.
Yeah.
Mm-hmm.
So we just do 6?
So it's going to be negative 6 divided by that
Yeah.
number that you got.
Okay, that's... How many 6s is that?
And on here, she thinks that it's decreased. So we're going to do the left tail.
Sorry, guys.
Okay, 0 point.
Negative 0.9?
Yeah, I got
Yeah.
0 point negative. Negative 0.9.
Okay, and I went and plugged it in, and I got 0.8159.
Wait.
You plugged
did
in
you
the
get?
applet?
Yeah. Oh, yeah.
We're just
'Cause I
finding
got-
the z-score right now, though. We're just solving the equation.
Yeah.
Mhm.
Okay, this might be a dumb question. Wait, for the z-score, though, we don't... Why are we square rooting it to the 36? Don't we normally not do that for the z-score, or do we do that now because we're doing hypothesis stuff?
We've always done it
what
because
was-
36 is the simple random sample for this
Sample.
specific problem.
Okay. So then our answer is negative 0.9.
Correct.
Well, it would
36.
put 0.9 because you can't have a negative 0. So don't put that. Don't put a 0 on the 16. On number 16, just put negative point.
Negative
Just
0.9?
put 0. Just put negative 0.9.
Negative 0.900. Because if you put negative 0.9, you're probably going to get it wrong because you can't have a negative 0.
Oh.
Oh.
Well, that's good to know. That's probably why I got so much wrong on
Yeah,
my
me
test.
too.
Oh,
negative
man.
0.99 or 0.900.
Yes.
That's really weird.
Okay, so then the next question is, what is the p-value associated with the z-score from the previous question? Okay.
Which is 0.816.
So we're looking for, if you look on the question, it wants, the alternative is saying that the mean is less than 150. So the z-score that we just found is for 150. So we're going to want to shade to the left.
Mm-hmm.
So we plug that in, shade to the left. Pull up my applet. Where's it at? Oh, I have to find my applet again.
So what did you, I got 0.184.
Yeah, that's what I got.
Okay.
Alright, I'll have to find that
Okay,
later.
so on 16, you got 0.900, and you plug that in. I got
Yeah.
point on the probability output when I plug that in and shade to the left.
Yeah, because this is less than 150.
So I got 0.8159.
Okay, so did you shade from you shaded to the left, but did you shade from only negative 0.9 or did you shade from positive 0.9?
I shade. Oh, whoa, that just changed. Oh, 0.184. Sorry, I shaded too much.
Okay.
Okay, so then what is 17? Because my applet's not pulling up.
It's 0.184.
0.
So did you put the 0 in that time, Mark?
I
Yeah,
did,
'cause it's a
yeah.
negative.
I always put in a 0 if it's positive, but if it's negative, never put in 0 because you can't have a negative 0. That number doesn't exist.
Okay, that makes sense.
Okay. You ready for 18?
Yep.
Okay.
Okay.
so-
What inference would you make about the null hypotheses for this problem?
So this is greater.
Okay, so
Okay.
So A is
0.05.
0.05.
0.05.
yeah. So this would be, we would have to reject it?
Remember the rule. Like,
Hold on,
if the
where-
p-value is less than a,
So
then you reject it.
smaller.
If it's greater
Yeah.
than a, then you fail to
Yeah.
reject it.
That's right. So we're failing to reject.
I'm still not comfortable with that. I'll practice more though.
Okay, what did you say? Greater you fail to reject.
Right. Less than you reject.
Less than you what?
If the p-value is less than the a value, then you're going to reject the null hypothesis. If the p-value is greater than the a value, then you're going to fail to reject the null.
Okay.
Okay.
I know, the way they word that was stupid.
I know. Greater, if it's greater than, you fail to reject. If it's less than A, then
Then
what
you do
would
reject.
then I do reject?
Yeah, you either reject or fail to reject. You can't accept a null hypothesis.
That wording.
Like, failing to reject is the same, like, just speaking in normal terms, failing to reject is the same as accepting it. So you either reject
Right.
it or accept it. But the wording that it wants you to use is fail to reject means that you accepted it.
Okay.
So if it's greater than we fail to reject.
Right.
Right. And p-value is less than A, then I do reject it.
Right.
Okay. I wrote
Okay.
that down again because I just.
Okay.
I just wrote P and then the less than sign. Like, I don't know if you can see it. I know. That's what I did.
Hold on, I can't see you. I'm looking at the test. Hold on. Where are you?
So I'm going to talk so that you guys can see my screen up there. Can you see that?
Okay.
So that's what I did, just to kind of make it easier for notes and stuff. If it's less than A, you reject it. If it's greater than A, you fail to reject it.
Okay.
Okay, that's much better. That's less words.
Exactly. Okay, so there are two types of errors that we made in performing. Which one involves rejecting the null hypothesis when the null hypothesis is true? That one is
It's type
Okay.
1.
Probability of type 1.
Okay, so what do we get for 18 then?
The second one.
18, fail to reject.
Fail reject. Okay. And then 19 is 1, right?
Right.
Because we. Okay.
okay. The researcher decided that instead of using a level of significance of alpha is 0.05, he'll use an alpha of 0.01. Which of the following will be true? The probability of a type 1 error will increase, or type 2 error will increase. Probability the null hypothesis is true will decrease. And his experiment will be more likely to be valid.
Okay, so hold on.
So when one increases, the other one decreases, right?
Yeah.
Right.
Probably the null hypothesis is true decrease.
So if we decrease the. What am I trying to say? So if we decrease one, the other will increase. So if we.
Okay, I
Right.
think it's the second one. Is it the second one?
If you're
It will
decreasing
increase.
the likelihood, if you're decreasing the likelihood of the A value, which is the likelihood of a type 1 error, then
Yeah.
you're increasing the type 2 error possibility, right?
Okay, so it's number 2 then, right?
Does that make sense?
Yeah, because we decreased A, so that will
Mhm.
increase the other one.
Yeah.
Right.
Okay.
Another thing to help remember is that B represents type 2 error. So if you're decreasing A, you're increasing B.
And vice versa.
Right.
Great.
Okay.
And so 20 is B then? And
Mhm.
21, I have no idea. If alpha is 0.05, compute the probability of committing a type 1 error.
Don't let this trip you out. This is probably the easiest problem on the homework test.
Oh.
Okay,
Okay.
how?
Okay, so remember the A value, that represents the probability of committing a type 1 error. Like, that is the definition. So the question is the answer. So if A is 0.05, then the probability is 0.05.
0.05. See, why they gotta do stuff like that?
But you put in 0.05.
I
Yeah.
put
Right.
0.050 just to give it 3 decimals.
Okay. Saving and submit. Okay, 100%.
Yay!
This is due tonight, isn't it?
Yeah. Oh no,
Yeah.
Saturday.
Saturday?
What's that? But the meeting's due tonight, right?
Oh, the meeting was due tonight.
Oh, then the homework's due Saturday.
Okay.
At least that's what it says on mine.
The homework is pretty easy. Like, if you understood what we just did, even just a little bit, you'll do okay on the homework.
Okay.
Okay, good. That's good to know. Thanks, Mark.
Yeah. Well, and I always, even if I know it, I always second guess it, and then I talk myself out of knowing the right answer.
I do. I did the same thing. That's why I like
I'm
talking
wrong,
to you guys,
so
because
whatever.
I can, like, maybe I should sit here and talk to myself while I'm doing my math. Maybe that'd be
All right,
helpful.
guys.
Okay,
Wonderful.
so thank you for recording for me. Would you,
I'll post the link. Don't worry about it.
if you want to post it?
I'll post it.
Okay.
Thank you so
All
much.
Thanks,
guys.
Jesse.
All right,
Bye.
we'll see you next week.
Everyone's help.
Yeah, have a good night. Bye.
Bye.